Hey guys, we're going to go over discrete and continuous random variables, and we're also going to go over the probability notation of it, okay? And we're also going to go over expected mean and standard deviation. All right, so this portion here is asking first for, it says patients receiving a hip replacement often experience pain after surgery. The pain is measured on a subjective scale with possible values of 1 low to 5 high. Let X be the pain score for a randomly selected patient. The following tables give part of the probability distribution for X. Okay, so here it says 1 being the lowest pain, so the probability of that being low is 0.1. So you notice it kind of starts increasing, and they have this missing one here, okay? Let's go ahead and start with the first question. So it says, find the probability that X is equal to 4. So this one's pretty straightforward. It tells you, given that X is equal to 4, what's the probability, and that's 0.3. Okay, so that's equal to 0.3. All right, now it's asking us, is pain score a discrete or continuous random variable? And we're going to go ahead and say that it's discrete because each value is assigned to a specific probability. Okay, so we're going to say discrete, and we're going to say because each value has a probability assigned. Okay. All right, next portion says find the probability of X less than or equal to 2. Okay, so we can do that. I'm going to put C here. All right, so the probability that X is less than or equal to 2 means the probability that X is equal to 2, and so we're going to add plus the probability that X is equal to 1. Okay, so all we need to do is basically figure out the probability of 2. X equal to 2 is 0.2. So 0.2 plus the probability that X equal to 1 is 0.1, which is 0.3. Okay, so these are pretty straightforward. All right, it's not too bad. All right, the next one it says compute the expected pain score and the standard deviation of the pain scores. Okay, this one's going to take a little bit longer than expected, so it's going to be, so we got to find the mean. So it's going to be the expected value is going to be 1 times 0.1 plus 2 times 0.2 plus 3 times 0.3 plus 4 times 0.3 plus 5 times, and we're going to need to figure out the rest. So if you remember that this, what needs to be true about this is that these, when you add them up, it needs to be equal to 1. So here 0.1 plus 0.2 is 0.3 plus another 0.3 plus another 0.3 is 0.9. So that means this remaining portion is 0.1. Okay? All right, so 1 times 0.1 is 0.1, plus 2 times 0.2 is 0.4, 3 times 0.3 is 0.9, so plus 0.9, 4 times 0.3 is 1.2, and this one here is going to be plus 0.5. Okay, so if you add these up, you get here a 0.5 plus 0.9 is 1.5, 1.4, I'm sorry. 1.4 plus 1.2 is 2.6, plus 0.5 is 3.1. So my average is 3.1. Okay? All right, so now it's asking us to figure out the standard deviation. So I'm going to get another sheet of paper here because it's going to be a little bit more work, okay? All right, so now to figure out the standard deviation, we got to remember that for this portion here, we have to get the summation of x sub I minus the mean squared times the corresponding probability, and we take the square root of that, okay? So I'm going to go ahead and figure that out, okay? So here we're going to start off with getting the corresponding value minus the mean, okay? So we're going to do 1 minus 3.1, okay? And we're going to do 2 minus 3.1, 3 minus 3.1, and 4 minus 3.1, okay? And then here we're going to get negative 2.1. Here's going to be negative 1.1. We actually forgot 1, sorry. 5 minus 3.1, okay? And here's going to be negative 0.1. Here's going to be 0.9. And here's going to be 1.9, okay? All right, now let me go ahead and what we're going to do next is we're going to be squaring them. So our next point here is to get x sub I minus mu sub x squared. So we're going to go ahead and square each one. So the first portion is 2.1 squared. I'm sorry, negative 2.1 squared is 4.41. 1.1 squared is 1.21. 0.1 squared is 0.01. 0.9 squared is 0.81. 1.9 squared is 3.61. Okay. Now the next one is going to be getting this portion here, the same thing. So this number times the corresponding probability. Okay. So if you guys look back over here, we have the corresponding probabilities here. Okay. So we're going to get 4.41, this number here, times the corresponding probability, which is 0.1. So times 0.1, which is 0.441. And the other one, it's going to be 1.21 times 0.2, which is 0.242. And the other one is going to be times 0.01 times the corresponding probability, which is 0.3, which is 0.003. And the other one is going to be 0.81 times 0.3 is going to be 0.243. And the last one, 3.61 times 0.1, which is 0.361. Okay. Now, what we need to do next is now we need to combine all these right here by doing the summation. So we're going to do the summation of all this right here. So x sub I minus mu sub x squared times pi. Okay, probability of I. I'm going to do 0.441 plus 0.242 plus 0.003 plus 0.243 plus 0.361. Okay, which is equal to 1.29. Okay. Now, taking the square root of this gives us this portion here. That's going to be your square root. So it's going to be the square root of 1.29, and that gives us 1.13, and we can round it off to 6 right here. Okay, and that's your standard deviation for that one. It's a lot of work, but this is how you work it out, okay? All right, so that one's that one right there. Okay, so now we have this next portion. It says, in the process for manufacturing glassware, glass stems are sealed by heating them in a flame. Let X be the temperature in degrees Celsius for randomly chosen glass. The mean and standard deviation of X are mu is equal to 550, and the standard deviation is 5.7. So it says, is temperature discrete or continuous? So here we're going to say it's continuous. And we can say because each value does not have a probability assigned to it. So for example here, each value, these are your values here, we don't have a probability assigned to each value. Okay? And there's gaps between each one. Here, temperature doesn't have any gaps between each one. You can have 5.5, you can have 550.3, so this is continuous, okay? All right, the next portion says here, how is the probability of X less than 540 related to the probability of X less than or equal to 540? So just for practice, what I'm going to do is I'm going to allow you guys to find the probability using the calculator of this one here. So the probability of X less than 540, okay, so here I'm going to show you guys how to do it in the calculator just for a refresher. So if you want the probability of 5 equals 40, we're going to get the second bars, and we want to know the area underneath the curve. So that means it's going to be less than. So that means when we do the bell curve, here we know that the mean is 550, and here's 540. So we want to know anything that's less than that. So we want to know the area of this portion here. So we're going to do, we have to have our lower bound. Our lower bound is the first one. So remember I told you guys to put negative 10,000 or something very large. And then up to your upper bound, which is 540, comma, and then also your mean. So they give us a mean, it's 550, comma, and then the standard deviation is 5.7. Okay, so that means that the area to the left of it is 0.039, so this is equal to 0.039. Okay, now to answer the question here, because we got this probability, now to answer this question how these two are related, we're going to say they're the same. And the reason being is because we're finding the area underneath the curve. And we find in the area underneath the curve, the area of this line here, if we have that, or if it's dotted, if it's there or not, the area is still going to be the same because the area of that line is 0. The width is 0 times whatever the length is, 0 times whatever the length is 0. So that's why it's not included.